She was my student a while ago. She doesn't want to seem old. But anyway, she's just here to see what's going on and basically just watch you guys. So be good. Just kidding. She's here to hang out today. You might be like her. Okay, you ready? Section 3.7. What were we doing? Stuff. Okay, that's good. That's not very helpful, but good. Differentials. And what were we working with? Linear. Here's reading the title. Okay. Linear approximation. What's the most important line in calculus besides when they say average or secant? Tangent. Okay, how do we find the equation of a tangent line? It's a forever card. Y minus y1 equals m times x minus x1. That's good, but oh, come on. There you go. The x1, y1. Who is that? Yeah, it's a particular x and a particular y, and we call it the point of louder. Tangency. Good. So what's so special about m? Calculus, right? Come on. Who's m? Is the derivative. Now, is it the derivative formula or a specific numeric derivative? Good. Okay, so with the tangent line, we learned to do really cool stuff like approximating. What did we do first? Square root of 9.3, then the square root of 1.1. Correct to pretty much the nearest hundredth, right? Then, ironically enough, you guys are ahead of period 6 right now. Because they argued a lot more about the switch one, right? But anyway, coming back. Cutting it short today. Got to focus. Finals are coming. We got to talk about the difference between dy and delta y, right? Now, we didn't get to do a lot of work, so we're going to peek at just a couple more things today. But dy, long story short, you guys should know this. Dy has something to do with... Okay, something to do with the change in a y value, but more specifically, dy dx, we've been learning all semester. That has to do with the derivative, right? So dy comes from a derivative. And if you guys notice, what's the only thing I did to dy dx equals f prime of x to get dy? Multiply both sides by dx. No big deal. Really? That's it? That's it. It's kind of more notation than anything. But we did talk about how Leibniz, whatevers, how he brought this notation in order to signify what was going on with the tangent line. And dy can approximate delta y. Delta y uses what to be solved? The change in y of the actual function itself. So we need to go ahead and have two different points of our function and then solve. Now, the cool thing in this class on Friday is that we got to actually solve for dy and solve for delta y for a problem. And guys, this is where it gets tricky because your brain is like, I don't know what's going on. But we just got to get the system down, yeah? Left-hand side. We started with y equals, it's just a function, right? Y equals delta? No, not delta. That's the square root. Okay. Square root of x. To get dy, what did we solve for? Yeah, just the derivative, right? Brought down to 1/2, negative 1/2. We got that one kind of memorized. 1 over 2 square root of x, moved dx, and we were done. But if we needed to solve given the specifics, all we got to do is plug it in, yeah? Plug it in, yeah? Solve. Okay, now we got 3/4 for that one. What did we do over here? And to be honest, the algebraic stuff, hey, just chill. This is actually the most confusing part. Because this one, even though it's algebra, it's technically like algebra 1 stuff, y2 minus y1, but it's a little weird what's given. So what is one x value we can plug in from the given information? 4, right? We can plug that one in, I got it. But where did 7 come from? 4 plus 3 because it's starting at 4, that's our initial point, right? And what did they tell us about delta x or change in x? Exactly. So maybe we should go back just one slide thinking about these types of applications. Can we change this delta y formula just a little bit to be in context of what we're going to see? And maybe I'll leave that little expression we had. It is f of x2 minus f of x1 or y2 minus y1. But if they give us one x and a delta x, how is this going to be solved? delta y equals f of x plus delta x minus f of, oh my goodness. That's half the definition of the derivative limit as, right? Delta x goes to 0, f of x plus delta x minus f of x all over delta x equals f5 of x. That you're supposed to be studying and playing around with you all week until Thursday, right? Okay. So what if I was to give you one more example? So let's say you are given, let's not be too crazy. F of x is equal to 3x squared plus 1. That's going to be a parabola. Find dy and delta y for, there's music going on. Let's say at let's just do 1. Alright. Follow the pattern. Let's see if you can do it. If you need any help, talk to people in your groups if your groups are here this morning. Hey, Laura, I'm sorry. Talk to the groups around you. Oh, it's going to go down. That's funny. Wait, Sarah. Start. Focus. Oh, is that who it is? He's always. Hey, are we solving dy? You gotta find the what? Derivative. It's easy. Oh, wait, they're all in band. Charlie's in band, Katrina's in band, Jason's in band, Lauren's in band. Brandon's not in band. I can't give you all day. Are we close? Follow the pattern. Can you follow it? Okay. Alright, dy. Alright, you guys start with the formula? Hold on, focus back on in my ones that were unfocused, my ones that were helping good, but we can't keep going. Dy, gotta find the derivative, right? What'd you guys get? 6x. I gave you an easy one, yeah? And then dx. So if they just wanted dy, and some of homework is going to ask that, some questions might ask that, they just want dy in general. Boom, done. But didn't I give you specific information? Yes. So how do you keep going? Oh, come on, sing the song. What do you do? You're so scared looking foolish. Dy is equal to? Alright, how we do? If you got it, push thumbs up. Why is it 1? I plugged in 2 because that's what x equals. Why did I plug in 1? Because that's what dx. Wait, because delta x is the same thing as dx, right? We can say that those are the same. Because you go over the same amount. Dy says go up to the tangent line. Change in y goes up to the function. Yeah, that's the difference. Okay, coming back. Speaking of differences, let's see if you get that reference. How do you find delta y? Thanks, Star. F of x2 minus. See? Difference. Okay. What's your x1?
2.
Got it. That's easy. Did you figure out the other one?
Yes.
How do you get it?
2 plus 1.
Got it. Track it?
Is
So
it
delta
always-
y.
Is it always like that? So the one they
If that's what's given, because what's given to you is an x and then a delta x, then you have to be able to get to the next x.
Right.
Now what?
Plug them in.
2? The original function, no derivative, sine chart, any of that craziness, right? So let's plug in the 3, 3 squared 9, 27, 28. You guys tracking? Do you check me? Oh, no blind faith.
You're good, Miss D.
Thanks. 2 squared 4, 12, 13, yeah?
Yep.
And then delta y. 15. Question, which one was the better approximate? This one, 12 and 15, because they're supposed to approximate each other. Or this one, 0.75 and 0.646. Why was this one a worse approximate if the delta x was even smaller? Remember, tangent lines are supposed to be good approximates, really close to the point of tangency. The other one's closer, and yet it's farther off. Anybody help me out based on the nature of the function?
That's the curve. It's a line.
Oh, with the parabola,
With the parabola.
the slope changes very rapidly. Increasingly.
Yeah, the slope is changing. The slope is increasing faster. Well, hold on. Isn't this slope decreasing?
Oh, yeah.
So if you were to do a tangent line, maybe the tangent line would be closer longer than a tangent line here. Does that make sense? Maybe this one would be closer by nature of the beast or nature of the function. That would be farther. Anyway, long story short, kiddos, 3-7 done. I've already taken out from the homework online. If you printed it out, scratch it, look online. I've already taken out this next topic, air propagation. It's cool. It's good. It's never on the AP. All right, let's keep going. Homework 23 due tomorrow.
Alright.
Let's go have some fun with French. Just kidding. He was a guy.
Jared Wire didn't shut up. He's like, Bopital.
Because he likes French and math, huh? Oh, Stapler made it back. I ignored you. Did you wait, Sarah?
No.
Did the stapler never make it to Sarah? You guys are horrible.
Alan!
I thought I was the
Oh, sorry. Alan, go ahead and pass it. Don't worry. No judgment. Safe place, guys. Come on. Okay. Test corrections. Pass it back. Pass them over. Alan, here's your job. They're all coming to you. You get them in the folder. Katrina is in band, along with Jason and Lauren. She plays saxophone. What does Katrina play?
She's in
Corey?
Oh yeah, Corey. That's what
And Caroline.
Oh, and Caroline. Brandon, sorry, I thought this was your CV. Okay.
Yeah, it's really good.
No, no.
I wouldn't do it Wednesday.
Whoa, we're in chapter 7? That's how smart you guys are.
Yeah.
Maybe Tuesday.
Maybe not. But we can do it because it has to do with limits and derivatives, and that's about it. It leads into Calc BC, but we're not going to Calc BC, not this year, so.
What chapter is it?
Steve hiring. She thinks her calculus teacher. Yeah, but they're like just super, super slow. Like 3 weeks in and they were on derivatives. They were on like power rules, yeah.
Where's she going to school?
UC Davis.
Okay.
What? You guys all start laughing. It's a good school. Do you like your college
Okay.
I loved my college.
Okay.
It was like a marathon and like be in the gym every morning.
Are you serious?
Yeah, because I would work in the gym and then go
Oh,
to
so you
class.
would see it. Let's go. And I went to USC.
Right.
Scout you probably didn't like it. He's like an adjunct and didn't know trigonometry and big mistakes. You guys got it? What on this? Ryan, Brittany. What in this list have you seen a lot before?
0, 0.
Woo! And what are you supposed to think? What were you supposed to write that some of you still don't write? Keep going, right? Why? Is 0 over 0 0? No. Is 0 over 0 1?
No.
Is 0 over 0 infinity?
No.
Not necessarily any of them. We don't know. It's indeterminate. We are unable to determine until we keep going, right? Sad thing is, did we just add a few more indeterminates? So infinity over infinity is not 1?
You know what infinity?
Infinity minus infinity is not 0? Not necessarily. 0 times infinity is not 0? Not necessarily. 0 to the 0 is not 0 or 1? Not necessarily. 1 to the infinity is not 1? What should you say? Not necessarily. Infinity to the 0 is not 1. Stink. So wait, anything with an infinity, can we not do fuzzy math with it? Remember we kind of did fuzzy math back when we were doing limits with like pretended plugging in infinity and we could kind of make conclusions? There are some things we can make conclusions about. These ones are determinate. These ones we can actually say what they are for certain. I can say infinity plus infinity is infinity. Pourquoi? Pourquoi?
They are in, like, includes infinity. So adding infinity is still
You just think increasing plus increasing is still increasing. Okay. How about the next one? Decreasing minus or
Decreasing.
plus more decreasing is still going to be decreasing. Remember, infinity is an idea, right? It's not a set number. It's not a set constant. So infinity, think positive infinity. You're approaching on a number line if we were to go that way. Just go all the way back. We're approaching to the right and then keep going right. Okay, go to the left. Keep going to the left. All right, you're going left.
The next constant.
0 to the infinity. All right, this one.
That's like 1 over 0.
No, not 1 over 0. Oh, you're talking about the last one. Hold on, not yet. 0 to the infinity. The hard thing is I can appeal to your logic, actually, on all of these. And I could probably convince you that all of these had answers when they don't. So I have to be careful with that. But for right now, we're just going to go ahead and say 0 to the infinity is 0. Goes to 0. Approaches 0. I should probably put it that way. And 0 to the negative infinity. Brandon, what were you saying about that a second ago?
Well, it become inverse. So 1 over.
Careful, don't say inverse, say
Reciprocal.
reciprocal. There we go. If 0 to the infinity is truly 0, 1 over 0 we know is an infinite form, right? Okay. Those ones we can determine. Those ones we can say are true, but all the rest we're in some pretty big trouble. Now, do you guys remember the old way of dealing with keep going? Dealing with limits that ended in, can you guys read it? Sorry, old way, algebraic manipulation. How would we keep going? Can I zoom in and have us work on it one by one? Okay. Old-fashioned way, oh my goodness, limits. The very first thing you should try, it's been a while, is to plug it in, right? And what happens when, I'm going to do it off to the side just to save space. What happens when we plug in negative 1? 0. Negative 1 plus 1, 0. Oh my goodness, keep going. How would we have done this one? That's for horizontal asymptotes, limits to infinity.
Pull out a 2.
Do some algebraic stuff like factor, right? Now, just to make it quick, remember, rewrite your limit. My little ones that never rewrote their limit and you ended up making mistakes because of it. Rewrite your limit. I'm going to go fast. Pull out a 2. X squared minus 1 is x plus 1, x minus 1, yeah? What can we do now? Oh, nice. It was a hole, right? 0 over 0, that's a hole in the graph, so if I can factor it out, I can say, even though there's a hole, the limit, what? Exists. Remember the video from the summer? 2 guys go into a diner? If they're going towards the diner, are they going to the same place? Yeah. Is the diner there? No. Burned down. Or a better way of saying it, they get to the door and they're like, I can't get in, it's locked. The owner's like, shut it for the day, whatever. Even though there's a hole, the limit exists. Now what do we do to finish? Plug it in. Negative 1 minus 1, negative 2 times 2, negative 4. My ones that make algebraic mistakes, show your work and get it right. You know what to do. Don't get it wrong. Negative 1 minus 1 is not 0. Okay. Number next one. Angela, now we need you. Degree test. Yeah. Okay, we know the answer is 3/2, but why on earth is this in the keep going section? can you go look at your indeterminate forms and figure out which form this one is? It's not 0 over 0. Richard, hang in there. Which one is it?
Oh yeah, it is infinity over zero.
If you plug in infinity squared, you can square infinity. Yeah, it's going to infinity faster. Infinity squared times 3 minus 1. Minus 1 doesn't really have much of an impact, right? Infinity squared times 2 plus 1. Ever increasing. It's technically this one. Do you see why infinity over infinity we can't just say is 1? Ratio of leading coefficients. Infinity over infinity, it depends on the degrees of the infinities, which is what we were doing with our horizontal test or our degree test all around. We can plug in infinity, but we can't make conclusions on infinity over infinity along with the other indeterminates. Degree test, 3 halves. Next one. What's going on here? Anything to the 0 power is, and 1 minus 1 is. Okay, it's a 0 over 0 again. Plug in e to the x. Can I pull an alpha? No. Can I do a super illegal thing that lots of Algebra 1 kids and some of you guys still do? Poor little puppy, dead. Side of the road, it's rough. Not the puppy. What's e to the 2x? A power times a power. Must have been a power raised to a power. You guys have hated this since pre-cal. But isn't it really just e to the x squared? Right? Power to a power you multiply? Pretty normal. We used to have to factor things with e to the x or like signs of x's and you guys hated it. But here's one application as to why. Rewrite the limit. We haven't taken it yet. Isn't the top just a difference of squares?
Yep.
Yeah. Because e to the x times e to the x is e to the 2x. You can think add the powers or you can think e to the x squared multiply the powers. Either way it ends up in the same place. And why on earth is that so stinking important?
Close it up.
There's a hole again that we could factor out. So far, algebra's been killing it. Well, this one was kind of a cheater, but plug in 0, e to the 0, 1, 1 plus 1 is dun, 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 dun. Last one. Okay, that's okay, that's okay. What happens when you plug it in? You guys are writing it down. Go ahead and think through how to plug in 0. e to the 0 is 1, 1 minus 1 is 0 over. Oh, okay, well no big deal. Algebra's been working this whole time.
I don't think it's gonna work.
Keep going. Factor. I could, but it doesn't cancel.
I don't think it's gonna work.
Rationalize. There's no square
I
root.
say we do that.
Well, set up creatively. Set up some weird thing and take ln of both sides.
Yeah.
I guess I could. ln of division is subtraction, but then I'm going to be stuck with this puppy. There's a line running. Anyway, you can't split that up. I'm going to be stuck. Some of you followed that, some of you didn't. ln is not going to work.
The first setup. Okay.
No. If you're allowed to use your calculator, back in limits, we would have said, alright, fine, nothing else we can do. Let's go to our calculator, put it in, go to the table. Can't we get infinitesimal? Not infinitesimal. Can't we approach on our calculator?
Yeah.
0.01, 0.001, 0.0001. Remember that?
Yeah.
Negative 0.01, negative 0.001. Make sure they agree. The limit exists if the limits agree. The limit does not exist if the limits do not agree. But we're in calculus. There's bound to be a better way. What would Jared Wire say? Loppy towns. We'll come back to that one. We can't solve it with algebra. We need loppy towns. Loppy towns, the final application of derivatives. In our book, it doesn't show up until 7-7. Once again, because it gets you ready, could get you ready for sequences and series, but we don't gotta worry about that. So we're doing it now at the end of derivatives, because all you need to be able to do is know for limits. Plug in, check. Recognize the indeterminate forms to say, uh-oh, keep going. And then just know how to take derivatives. L'Hopital's. Let f and g be functions that are differentiable on, hold on. The AP, starting this year, is going to be spelling it like that. Change the spelling. L'Hopital. Say it the same way. Don't call it the hospital, I suppose you can. Just we're all going to be cringing. There are two alternate spellings. This is actually a dude. This is a guy. He found the rule. Well, at least. Oh, that's right. We have 5 fewer minutes. Hold on, pause. We're going to start here tomorrow. Remember, we were just starting today. But, long story short with L'Hopital's, I just want to show it to you. Back here. We already figured out 0 over 0, right? L'Hopital says, given some conditions, guess what we can do? Take the derivative, not quotient rule. Take derivative of the top, take derivative of the bottom separately, not quotient rule. And plug it in, plug it in. Woo! How interesting. Bye, guys. Technically, I'll be here until mission meeting tonight at 6, but I might have to run off campus, so we'll say 5. Bye, focus. Class correction. Ready as the day if you
Nope. I don't think so, because I was.
Bye, guys.
I won't be able to.